Hi. Hi. Let's start today's session. Let's start today's session. As I remember, maybe in last session the light has gone, that's why session was ended unexpectedly. Let's check up to which point we have done practical workload in previous session. So as we checked, we have renewed certificate and we were in next stage, but session were disconnected or ended due to light has gone, so let's continue from replacing certificate. The imported certificate will be first exported by VMCA. First we will import certificate, then we will replace her with old one. First we will import certificate, then we will replace her with old one. The imported certificate will be first exported by VMCA by default in center server, and when we import from VMCA, then we can replace that certificate with old one. The imported certificate will be You can see how to renew, import, replace, and generate. Please view other actions for other certificate management. The VMware Certificate Authority provisions your environment with certificates. Certificates include machine SSL certificates for secure connections, solution user certificates for authentication of services to vCenter single sign-on, and certificates for ESG hosts. These default certificates are not signed by a commercial certificate authority. You can replace default vCenter server certificates with certificates signed by a commercial CA. Certainly. VMware vSphere is a powerful virtualization platform used to create and manage virtualized environments. VSGX Secure Enclaves is a feature within vSphere that enhances security by providing a dedicated, isolated environment for running sensitive workloads. Here's an easy-to-follow explanation of how to use VSGX Secure Enclaves. 1. Understanding VSGX Secure Enclaves. VSGX Secure Enclaves is a feature in VMware vSphere designed to enhance security by creating isolated environments called enclaves where sensitive workloads can run. These enclaves are protected from unauthorized access and provide a high level of security for critical applications and data. These enclaves are protected These enclaves are protected from unauthorized access and provide a high level of security for critical applications and data. 2. Preparing your environment. Ensure you have a VMware vSphere environment set up and running. Verify that your hardware supports Intel SGX technology, which is used by VSGX. 3. Enabling VSGX secure enclaves. Access the vSphere web client interface. Navigate to the cluster or host where you want to enable VSGX. Go to the Configure tab and select Security and Services. Enable Intel Software Guard extensions if it's not already enabled. Once enabled, create a new VSGX secure enclave. This can typically be found under the Security section of your vSphere management interface. 4. Creating a secure enclave. Click on Create Enclave or similar option. Provide a name for your enclave and specify its properties, such as CPU and memory resources. Choose the level of security you require for the enclave. Specify which VMs will be part of this enclave. 5. Configuring security policies. Set up security policies to define who can access the enclave and under what conditions. Configure access control lists to restrict access to authorized users or roles. Implement encryption and other security measures to protect data within the enclave. 6. Deploying workloads. Create or migrate VMs into the secure enclave. Ensures that all sensitive applications and data are running within the enclave. Monitor and manage the workloads running inside the enclave to maintain security and performance. 7. Regular maintenance and monitoring. Regularly review security policies and access controls to ensure they meet your organization's requirements. Monitor the performance and security of the secure enclave and its workloads. Keep up to date with patches and security updates provided by VMware to address any vulnerabilities. By following these steps, you can effectively utilize VSGX secure enclaves in VMware vSphere to create a secure environment for running sensitive workloads while ensuring high levels of isolation and protection. Good evening. We have a packed show for you, including
Hope you all understand what is secure enclave.
With Word, you can bring your applications.
Hope you all understand what is secure enclave.
Hope you all understand what is secure enclave.
Hope you all understand what is secure enclave.
Welcome to Jenny. Just click listen or type your own text here.
You know I have this question in mind. Let me first tell you about my question, then we will find accurate and precise answer, okay? So my question is that, like for example, as you said, that sensitive workload or virtual machines are kept in place known as enclave or secure enclave, where these are secure and non-authorized user cannot access those sensitive workloads or virtual machines. So then tell me, is it means that virtual machines outside of enclave means those VMs which have passwords to log in vCenter server, and there are also authentication available in vSphere. So if all kind of security is available, then why we need secure enclaves to keep virtual machines secure with itself? Kindly explain my query with points in easiest way. So let's know the answer. Sure. Let's break it down into simple points. 1. Extra layer of security. Asterisk. Secure enclaves provide an additional layer of security beyond traditional access controls. Even with passwords and authentication, there could be vulnerabilities or risks of unauthorized access. 2. Isolation from unauthorized access. Asterisk. Enclaves ensure that sensitive workloads are completely isolated from non-authorized users. While regular VMs have login protections, enclaves provide a more stringent level of isolation. 3. Protection from insider threats. Asterisk. Enclaves protect against insider threats where a user with legitimate access might misuse it. Regular VMs might still be vulnerable if an authorized user intentionally or unintentionally causes harm. 4. Enhanced security for critical workloads. Asterisk. Enclaves are especially useful for critical workloads handling sensitive data or applications. They provide a dedicated, highly secure environment for these critical operations. 5. Hardware-level security. Asterisk. Secure enclaves leverage hardware-level security features. Enclaves are especially useful for critical workloads handling sensitive. Enclaves protect. While regular VMs have login protections, enclaves provide a more stringent level of isolation. 3. Protection from insider threats. Asterisk. Enclaves protect against insider threats where a user with legitimate access might misuse it. Regular VMs might still be vulnerable if an authorized user intentionally or unintentionally causes harm. 4. Enhanced security for critical workloads. Asterisk. Enclaves are especially useful for critical workloads handling sensitive data or applications. They provide a dedicated, highly secure environment for these critical operations. 5. Hardware-level security. Asterisk. Secure enclaves leverage hardware-level security features. like Intel SGX, for added protection. This hardware-level security ensures that even if there are software vulnerabilities, the enclave remains secure. 6. Compliance requirements. Asterisk. Enclaves help meet compliance requirements for data protection and privacy regulations. They provide a more robust security posture, which is often required for compliance with industry standards. 7. Reduced attack surface. Asterisk. By isolating sensitive workloads into enclaves, the attack surface is reduced. This minimizes the risk of unauthorized access or exploitation of vulnerabilities. 8. Customizable security policies. Asterisk. Enclaves allow for the customization of security policies specific to the sensitive workloads. You can define access controls, encryption, and other security measures tailored to your requirements. 9. Risk mitigation. Asterisk. Enclaves mitigate risks associated with shared infrastructure environments. Even if there's a breach elsewhere in the environment, enclaves remain secure. 10. Peace of mind. Asterisk. Using enclaves provides administrators and organizations peace of mind regarding the security of their most critical assets. It's like having a secure vault within your virtual infrastructure for your most valuable possessions. In summary, while vSphere offers robust security features like passwords and authentication, secure enclaves provide an extra layer of protection, especially for critical workloads handling sensitive data, by leveraging hardware-level security and isolation. They offer peace of mind and help meet compliance requirements effectively. Hope you people also got answer of a question I have in mind after knowing about secure enclave functions and role in vSphere. Now let me repeat my question. Was that why we need secure enclave if it functions of securing sensitive data is already arranged by vSphere? So I got the answer. As I understand, we need secure enclave BEQs to add extra layer of security protection. And also if there is internal threat, like for example someone knows the passwords of VM, or authenticated user or internal user can access VM and he can intentionally or unintentionally harm VM workload, so they cannot, because which VMs are insecure in Larvae, they're isolated from normal VMs which are out of secure enclave in vSphere. Now what you understand, write in comment box. Hope you people also got answer of a question I have in mind after knowing about secure enclave functions and role in vSphere. Now let me repeat my question. Was that why we need secure enclave if it functions of securing sensitive data is already arranged by vSphere? So I got the answer. As I understand, we need secure enclave BEQs to add extra layer of security protection. And also if there is internal threat, like for example someone knows the passwords of VM, or authenticated user or internal user can access VM and he can intentionally or unintentionally harm VM workload, so they cannot, because which VMs are insecure in Larvae, they're isolated from normal VMs which are out of secure enclave in vSphere. Now what you understand, write in comment box. Now let's move forward, okay? Virtualization is a pretty revolutionary idea, adding a layer of software to help solve other problems in IT. From a risk perspective, though, it adds another set of issues to track. This isn't to say that vSphere is insecure, far from it. vSphere is secure, and probably the most secure hypervisor around. Our common criteria certifications help demonstrate this. For example, when an application has a secret, like an encryption key or the location of secret bases, the secret is visible to a lot of layers. First, it's stored in system memory and in the CPUs. Second, the hypervisor can see it. Third, the guest OS can see it. And last, of course, the application. Intel Software Guard extensions allows an application to conspire with the CPU to keep secrets from the guest OS and the hypervisor, and thereby eliminate them from the risk equation. Starting with vSphere 7, some applications started to use this functionality, exposed to VMs running minimum hardware version 17. vSphere 8 is a universal application acceleration. vSphere 8 is a universal application platform that supports broad variety of workloads, including 3D graphics, big data, HPC, machine learning, in-memory, and cloud native, as well as existing mission-critical applications. It also supports and leverages some of the latest hardware innovations in the industry, delivering exceptional performance for a variety of workloads. Another process that was improved was the memory copy. Prior to vSphere 7, memory was transferred between the hosts in 4K pages, and starting from vSphere 7, it now uses 1 GB pages, along with a few other optimizations, to make this data transfer much more efficient. To make sure the stun time stays within the 1-second target, the time when the switch over between hosts occurs, the VM state and the bitmap of the memory pages are transferred. This stun time is important, and with very large VMs, it becomes difficult to transfer that bitmap in less than the desired 1 second. So, instead of transferring the entire bitmap, which could be hundreds of megabytes in size for large VMs, only the pages required are transferred. Most of the pages are actually already on the destination host from the original transfer, so we can reduce the transfer time from seconds to milliseconds. Enhancements to NVIDIA Grid vGPU. From vSphere 7, VMware started to further enhance the support and capabilities introduced for GPUs through VMware's collaboration with NVIDIA by virtualizing NVIDIA GPUs for non-VDI and use cases such as artificial intelligence, machine learning, big data and more. Since vSphere 6.7, the co-developed NVIDIA vGPU solution already allows for workload portability, even live migrations using vMotion as of vSphere 6.7 Update 1, or suspend and resume VMs running on GPUs instead of powering off these workloads as of vSphere 6.7 Update 2. With enhancements to NVIDIA Grid vGPU technology in vSphere 7 and assignable hardware, the workload placement is improved for vGPU-enabled virtual machines. Assignable hardware is a framework developed to extend the support for vSphere features when customers utilize hardware accelerators. It introduces vSphere DRS, initial placement, and vSphere HA support for VMs equipped with a pass-through PCIe device or a NVIDIA vGPU. Assignable hardware will verify the availability of the vGPU profile that is selected for the virtual machine. Assignable hardware. vSphere 7 introduced a framework called assignable hardware that was developed to extend support for vSphere features when customers utilize hardware accelerators. It introduced vSphere DRS for initial placement of a VM in a cluster, and vSphere High Availability (HAR) support for VMs equipped with a pass-through PCIe device or a NVIDIA vGPU. Related to assignable hardware is the new Dynamic Direct Path I/O, which is a new way of configuring pass-through to expose PCIe devices directly to a VM. The hardware address of a PCIe device is no longer directly mapped to the configuration VMX file of a virtual machine. Instead, it is now exposed as a PCIe device capability to the VM. Together, Dynamic Direct Path I/O, NVIDIA vGPU, and assignable hardware are a powerful new combination unlocking some great new functionality. For example, let's look at a VM that requires an NVIDIA V100 GPU. Assignable hardware will now interact with DRS when that VM is powered on, initial placement, to find an SSH host that has such a device available, claim that device, and register the VM to that host. If there is a host failure and vSphere HAR kicks in, assignable hardware also allows for that VM to be restarted on a suitable host with the required hardware available. First, understand this paragraph. Okay, it is about feature known as assignable hardware in vSphere so the paragraph you should try to understand is, together, Dynamic Direct Path I/O, NVIDIA vGPU, and assignable hardware are a powerful new combination unlocking some great new functionality. For example, let's look at a VM that requires an NVIDIA V100 GPU. Assignable hardware will now interact with DRS when that VM is powered on, initial placement. To find an SSH host that has such a device available, claim that device, and register the VM to that host. If there is a host failure and vSphere HA kicks in. Assignable hardware also allows for that VM to be restarted on a suitable host with the required hardware available. Now my question is that if host fails in high availability feature of vSphere, obviously the VMS will be migrated on host, which is okay, and have resources for running that VM which was on host, which is failed now. So in paragraph, they said like assignable hardware will restart VM on another host. So is this not the actions or work of high availability feature instead of assignable hardware feature? So let's know the answer now. I see, you're asking about the roles of high availability, HA, and assignable hardware features in VMware vSphere, based on the provided paragraph. Let's break it down. 1. High availability, HA, feature. HA is a feature in vSphere that ensures VMs are restarted on other hosts in the event of a host failure. When a host fails, HA detects this and restarts the affected VMs on other hosts within the cluster. HA doesn't necessarily ensure that the VMs are placed on hosts with the exact same hardware resources as the failed host. 2. Assignable hardware feature. Assignable hardware is a newer feature that dynamically assigns hardware resources to VMs based on their requirements. It interacts with features like Dynamic Direct Path I/O and NVIDIA vGPU to allocate specific hardware resources to VMs. In the example given, assignable hardware is used to ensure that VMs requiring specific hardware, like an NVIDIA V100 GPU, are placed on hosts with compatible hardware. Now, let's clarify the actions described in the paragraph. Initial placement, VM power on, *. When a VM requiring an NVIDIA V100 GPU is powered on, assignable hardware works with DRS, Distributed Resource Scheduler, to find a host with that GPU available. It claims the GPU on that host and registers the VM to run on that host. This ensures that the VM starts on a host with the required hardware, optimizing performance. High availability, host failure, *. If the host running the VM fails, HA detects this and initiates VM restarts on other hosts. Assignable hardware comes into play here by ensuring that when the VM is restarted, it's placed on a suitable host with the required hardware available. So, if a host with an NVIDIA V100 GPU fails, HA will restart the VM on another host with a compatible GPU, thanks to assignable hardware. Answering your question. Yes, HA handles the migration of VMs to other hosts in case of a failure. However, assignable hardware ensures that when VMs are restarted, they are placed on hosts with the necessary hardware, optimizing their performance. So, while HA ensures availability, assignable hardware ensures that VMs continue to run optimally by being placed on hosts with the right hardware resources. In essence, While HA handles VM restarts, assignable hardware ensures that VMs are restarted on hosts with compatible hardware to maintain optimal performance. Okay, I understand, but again I need clarification, as you already said if host is field, then HA ensure to restart VM on another host, which have enough resources for that VM, but you also said that assignable hardware is latest and new feature in vSphere, so it was not available in old vSphere versions. Then how HA were working when this actionable hardware feature, as you said, is latest only available in new versions of vSphere, so clarify please how then in old versions the VM were migrated to those hosts which would have enough resources for that VM to run. Hope you understand my question and give me answer in points. So let's clarify ourselves by getting proper answer now. Certainly, I understand your question. Let's clarify how high availability, HA, worked in older versions of vSphere before the introduction of assignable hardware. 1. Resource-based VM restart. In older versions of vSphere, HA relied on a resource-based approach for VM restarts. When a host failed, HA looked for other hosts in the cluster with enough available CPU and memory resources to restart the VMs that were running on the failed host. 2. Restart priority and admission control. HA used restart priorities and admission control policies to determine which VMs should be restarted first and if there were enough resources available for them. VMs with higher restart priorities would be restarted first, and admission control ensured that there were enough resources in the cluster to accommodate all high-priority VMs. 3. Host affinity rules. Asterisk. HAR allowed administrators to set host affinity rules to specify which hosts VMs should and should not be restarted on. This helped ensure that VMs were restarted on hosts with similar hardware configurations to the failed host. 4. Cluster-wide resource pooling. Asterisk. vSphere clusters pooled CPU and memory resources across all hosts in the cluster, allowing for efficient resource utilization and VM placement. HAR could utilize these pooled resources to restart VMs on hosts with available resources, even if they didn't match the exact hardware of the failed host. 5. Manual VM placement. Asterisk. In some cases, administrators could manually specify the host for VM restarts if needed, ensuring VMs were placed on hosts with specific hardware requirements. 6. Limitations. Asterisk. However, without assignable hardware, HAR couldn't guarantee placement on hosts with exact hardware configurations. VMs might be restarted on hosts that lacked specific hardware accelerators or other specialized resources, potentially impacting performance. In summary, before the introduction of assignable hardware, HAR in older versions of vSphere relied on resource-based VM restarts, restart priorities, admission control policies, and host affinity rules to ensure VM availability. While it could efficiently utilize available resources, it couldn't guarantee placement on hosts with the exact hardware required for optimal performance, which assignable hardware now provides in newer versions of vSphere. Yes, but tell me also about that if there is no host which can complete specified requirements for VM to restart on another host, then how assignable hardware feature can work? Answer in one paragraph simply. If there's no host available that meets the specified requirements for a VM to restart on, assignable hardware feature will wait until such a host becomes available. It essentially holds off VM restart until a suitable host with the required hardware resources, like GPU for example, is added to the cluster or becomes accessible. This ensures that the VM restarts on a host that can provide the necessary resources, maintaining optimal performance and functionality. You people know what web are now completely cleared how assignable hardware feature works and what relation it have with high availability feature of vSphere. vSphere 8 expanded the usage of vGPUs by increasing the number of vGPUs from 4 to 8 per VM. Reduce AI, ML model training time and run higher-end models with large datasets by scaling the number of available GPU resources, and improve direct path I/O count to speed up development of AI, ML workloads by scaling out GPU resources to run multiple AI, ML models simultaneously. vSphere 8 expanded the usage of vGPUs by increasing the number of vGPUs from 4 to 8 per VM. Reduce AI, ML model training time and run higher-end models with large datasets by scaling the number of available GPU resources, and improve direct path I/O count to speed up development of AI, ML workloads by scaling out GPU resources to run multiple AI, ML models simultaneously. Lastly, I understood about latest feature in vSphere, which is assignable hardware which moves VM on another host when its available host is failed to that host which have enough resources. So I am giving you some paragraphs and try to tell me about how assignable hardware feature works additionally. Without like moving VM to that host which have enough resources, assignable hardware. vSphere 7 introduced a framework called assignable hardware that was developed to extend support for vSphere features when customers utilize hardware accelerators. It introduced vSphere DRS for initial placement of a VM in a cluster, and vSphere High Availability (HAR) support for VMs equipped with a pass-through PCIe device or a NVIDIA vGPU. Related to assignable hardware is the new Dynamic Direct Path I/O, which is a new way of configuring pass-through to expose PCIe devices directly to a VM. The hardware address of a PCIe device is no longer directly mapped to the configuration VMX file of a virtual machine. Instead, it is now exposed as a PCIe device capability to the VM. Together, Dynamic Direct Path I/O, NVIDIA vGPU, and assignable hardware are a powerful new combination unlocking some great new functionality. For example, Let's look at a VM that requires an NVIDIA V100 GPU. Assignable hardware will now interact with DRS when that VM is powered on. Initial placement. To find an SSH host that has such a device available, claim that device, and register the VM to that host. If there is a host failure and vSphere HA kicks in, assignable hardware also allows for that VM to be restarted on a suitable host with the required hardware available. vSphere 8 expanded the usage of vGPUs by increasing the number of vGPUs from 4 to 8 per VM. Reduce AI, ML model training time and run higher-end models with large datasets by scaling the number of available GPU resources, and improved direct path I/O count to speed up development of AI, ML workloads by scaling out GPU resources to run multiple AI, ML models simultaneously. Certainly. Assignable hardware in vSphere 7 introduced a framework to support hardware accelerators, enabling features like vSphere DRS and vSphere HA for VMs equipped with pass-through PCIe devices or NVIDIA vGPUs. Dynamic Direct Path I/O was also introduced, which configures pass-through to expose PCIe devices directly to VMs, no longer mapping the hardware address directly to the VM's configuration file. Assignable hardware, Dynamic Direct Path I/O, and NVIDIA vGPU work together to unlock new functionalities. For instance, when a VM requiring an NVIDIA V100 GPU is powered on, assignable hardware interacts with DRS to find a host with the required GPU, claims the device, and registers the VM to that host. If a host failure occurs, vSphere HA kicks in and assignable hardware ensures the VM restarts on a suitable host with the necessary hardware. In vSphere 8, the usage of vGPUs was expanded, allowing up to 8 vGPUs per VM. This enhancement speeds up AI, ML model training and allows for running higher-end models with larger datasets. Additionally, the improved direct path I/O count accelerates the development of AI, ML workloads by scaling out GPU resources to run multiple models simultaneously. So remember, in vSphere 7 only 4 vGPUs were allowed, but in vSphere 8 it were not 4, it were 8, means per VM only 8 vGPUs were allowed. We have completely understood these topics now. 1. High availability, HAR. 2. Assignable hardware. 3. Direct path I/O. 4. NVIDIA vGPU. And you know that this assignable hardware feature works with 1. HAR. 2. DRS. 3. Direct path I/O. 4. NVIDIA vGPU. XP plane in 5 small steps from basics, VSP here Distributed Services Engine, in vSphere. Sure. Here are 5 small steps to understand the basics of vSphere Distributed Services Engine, in vSphere. 1. Introduction to vSphere Distributed Services Engine, VDSE, *. VDS Engine is a component of VMware's vSphere virtualization platform. It's responsible for managing network services and policies in distributed virtual environments. 2. Centralized network management, *. VDSE centralizes network configuration and management across multiple SG hosts in a vSphere cluster. It VDSE centralizes network configuration and management across multiple SG hosts in a vSphere cluster. It provides a single point of control for defining network settings and policies. 3. Enhanced network services, *. VDSE offers advanced network services such as distributed switching, load balancing, and traffic shaping. These services ensure optimal network performance, scalability, and reliability for virtualized environments. 4. Integration with vSphere Distributed Switch, VDS, *. Integration with vSphere Distributed Switch, VDS, asterisk. VDSE tightly integrates with the vSphere Distributed Switch, VDS. VDS is a software-based network switch that spans multiple SSH hosts, enabling consistent networking across the entire vSphere environment. 5. Benefits of VDSE, asterisk. Simplified network management. VDSE streamlines network configuration and policies. Enhanced performance. VDSE improves network efficiency and performance through advanced services. Scalability. VDSE scales seamlessly with growing virtual environments, ensuring consistent network management across the infrastructure. As you said, VDSE centralizes network configuration and management across multiple SSH hosts in a vSphere cluster. So say yes or no. Is VDSE cluster-level feature? Apologies for the confusion. VDSE, vSphere Distributed Services Engine, is indeed a cluster-level feature within vSphere. It operates across the entire vSphere cluster, managing network configuration and policies for all SSH hosts within it. VDSE provides centralized management, ensuring consistency and efficiency in network settings across the cluster. It tightly integrates with vSphere Distributed Switches, VDS, which span multiple hosts, and facilitates high availability of network services by seamlessly transferring configurations and services in case of host failures. In essence, VDSE simplifies network management by providing a single point of control at the cluster level, enhancing performance, scalability, and reliability of the virtualized environment. So as of my understanding, if VDSE centralize network management policies on advanced level and work with vSphere distributed switch, which obviously not works on cluster level, but works across all SG hosts added in vCenter server. So as I understand, VDSE is not cluster level but whole vCenter level feature. Am I right or wrong? If right, why? And if wrong, why? Answer in 2 paragraphs. Okay. You're partially correct. VDSE, vSphere Distributed Services Engine, does indeed centralize network management policies and works with vSphere distributed switches, VDS, across all SG hosts added in vCenter server, which suggests it's not strictly a cluster-level feature but operates at a broader level. However, VDSE's integration with vSphere distributed switches doesn't necessarily make it a vCenter level feature. Instead, VDSE functions at the level of vSphere clusters within vCenter server, allowing for centralized management of network configurations and policies across multiple SG hosts within a cluster. This means that while VDSE operates across all hosts managed by vCenter server, its primary scope is within vSphere clusters, ensuring consistent network management within these clusters. In summary, VDSE is not strictly a vCenter level feature, but rather operates at the level of vSphere clusters within vCenter server. It provides centralized network management across all SG hosts within a cluster, integrating with vSphere distributed switches to ensure consistent network configurations and policies. While it spans all hosts within a vCenter environment, its primary focus is on managing network resources and services within individual clusters, making it a cluster-level feature rather than strictly a vCenter level one. Okay, let me ask a general question. If we have two scenarios. Scenario A. We have 10 SSH hosts added in vCenter server, so obviously all SSH hosts have its own individual resources, and they cannot use another SSH host's resources. Scenario B. We have same 10 SSH hosts added in vCenter server, but vCenter server have 5 clusters. Okay, so each cluster have 2 hosts added, so in each cluster can any host use another host's resources within the cluster, because in cluster when hosts are added, their resources are combined and can be used by any virtual machine. But clarify me that if VM needs 4 GB RAM first and SSH host 1 have 8 GB RAM and SSH host 2 have 12 GB RAM and it is running on SXI host 1, so tell me that if VM requires more RAM, like need extra 6 GB RAM, so obviously its RAM total requirement would be 10 GB RAM, so on which hosts it is running that have only 8 GB RAM and another hosts in cluster which is SSH host 2 which have 12 GB RAM, so that virtual machine can run on same hosts if both host resources are combined in cluster, or no, that virtual machine will be moved to SSH host 2. Hope you understand and clear my each point in deep. In scenario B, where there are 10 SSH hosts added to vCenter server, each grouped into 5 clusters with 2 hosts per cluster, the resources of each host in a cluster are pooled together to some extent, but it doesn't mean that a virtual machine can use resources from another host within the cluster automatically. Let's break it down. 1. Resource pooling within clusters. Asterisk. In each cluster, the resources of the 2 hosts are pooled together to provide better resource utilization and high availability. This pooling allows for distributed resource scheduler (DRS) to balance the workload across hosts in the cluster based on resource utilization. 2. Virtual machine resource requirements. Asterisk. If a virtual machine running on SSH host 1 requires additional resources beyond what host 1 can provide, DRS does not automatically move the virtual machine to host 2 to utilize its resources. DRS monitors resource usage and may recommend or automatically move virtual machines between hosts in the cluster to balance resource usage, but this is typically done for load balancing or to optimize performance rather than to address resource shortages for individual VMs. 3. Memory overcommitment. Asterisk. It's important to note that memory overcommitment is possible in vSphere, meaning that the total memory allocated to virtual machines across hosts in a cluster can exceed the physical memory available in the hosts. However, this doesn't mean that a single virtual machine can use memory from multiple hosts simultaneously. 4. Dynamic resource allocation. Asterisk. DRS continuously monitors resource usage and can migrate virtual machines between hosts to ensure efficient resource allocation. If a virtual machine's resource demands increase beyond what its current host can provide, DRS may move it to another host with available resources. 5. Response to your scenario. Asterisk. In your scenario, if a virtual machine requires 10 GB of RAM and it's running on SSH host 1 with only 8 GB of RAM, DRS may decide to migrate it to SSH host 2 if it has enough available memory to meet the VM's requirements. DRS makes such decisions based on resource usage and cluster-wide availability, considering factors like CPU, memory, and network usage. In summary, while resources are pooled within clusters in vSphere, individual virtual machines cannot directly use resources from multiple hosts simultaneously. However, DRS dynamically manages resource allocation and may migrate virtual machines between hosts within a cluster to ensure efficient resource utilization and meet VM requirements. Okay, if there is not host which can complete requirements, then what? And also add this quasiton as well, that is it possible that in cluster SG host 2 resources can be shared with SG host 1 within cluster, and VM can run on same host with less RAM without moving VM to another host because first host have less resources. If there's no host in the cluster that can meet the resource requirements of a virtual machine, then the virtual machine will remain on its current host, even if that host doesn't have enough resources to fulfill its requirements. In this case, the virtual machine may experience resource contention or performance degradation due to resource constraints. Regarding the possibility of sharing resources between SG hosts within a cluster, no, it's not possible for SG host 2's resources to be directly shared with SG host 1 within the cluster. Each SG host within a cluster manages its own resources independently. However, in scenarios where a virtual machine requires additional resources beyond what its current host can provide, vSphere's Distributed Resource Scheduler, DRS, can migrate the virtual machine to another host in the cluster with adequate resources. This migration ensures that the virtual machine has access to the necessary resources without sharing resources between hosts. So, the virtual machine may be moved to a host with more resources if needed, rather than running on the same host with insufficient resources. If you say again and again like this, then why we need cluster and why we add all hosts resources in cluster. Hope you got what I said. I understand your concern. Let me clarify. The purpose of clustering in vSphere is to provide high availability, resource pooling, and resource management across multiple hosts. When you add hosts to a cluster, it allows vSphere to manage resources more efficiently by pooling together the resources of all hosts in the cluster. This pooling enables features like Distributed Resource Scheduler, DRS, and High Availability, HA, to optimize resource usage and ensure better availability of virtual machines. However, it's important to note that while resources are pooled at the cluster level, individual virtual machines still have specific resource requirements that need to be met. If a virtual machine's resource requirements exceed what its current host can provide, vSphere's features like DRS and HA will attempt to address this by moving the VM to a host with adequate resources. In summary, clustering and resource pooling enhance overall resource utilization and availability, but virtual machines still have specific resource requirements that must be met, and vSphere's management features work to ensure those requirements are fulfilled within the constraints of the cluster.